All right, ladies and gentlemen, we're going to go ahead and continue with our Module 5 notes. I'm recording from home today, which means you will probably hear my children screaming in the background. Just go ahead and ignore that. Okay. All right, we are going to take a look at Module 5, Lesson 10. Now, this is going to look pretty familiar in the beginning when I write area of rectangles. And many of you hopefully thinking, oh, we've been doing that as part of our volume. Oh, we did that in 4th grade. True. But we're going to stretch it a little bit. We're also going to include some fractions. Now, I'm going to say fractions, but I want you to keep in mind fractions could mean mixed numbers, could mean decimals. You'll see that in a moment. All right. Module 5, Lesson 10 means we get a Roman numeral 10. So there's our X right there. Okay. We'll start with some vocabulary, and I'm hoping that this vocabulary will also be fairly familiar. Again, my hope is that this is something you are familiar with. We're just kind of taking it to the next level. So we'll start with the obvious. Let's talk about what area is. Okay. Hopefully you know that area is the space covered. The space covered by a flat shape. Now for us, we're going to be dealing with rectangles, but as you get older and apply this to triangles and circles and other things, it's the same. The space covered by a flat shape measured in square units. Okay, we'll talk about square units in a minute. You know what those are, hopefully, but we'll review just in case. Area is 2D. It's two-dimensional. It's flat. It deals with length, and it deals with width. Okay. Speaking of which, let's go ahead and put our formula here. We remember that area equals length times width. Now, we're going to talk a little bit more today, again, about why that works, why that formula is so helpful. We're going to draw some pictures, though, before we get straight to the formula. All right, so we mentioned square units. Let's talk about what those are in a little more depth. Square units. Square units you can think of as the flat square. Now I'm going to use the word tiles, because honestly that's the example we use most of the time. I'm covering something with tiles. Flat square tiles that are used to measure area. Now, are they always tiles? No. Are they always squares? Yes. Or, as you get older, parts of squares. Okay? So the flat square tiles used to measure area, and we write these as whatever the unit is. So if it's centimeters, inches, feet, the unit squared, square units. Okay? All right, number 3. This one, again, I'm really hoping is super review. This is going to be a mixed number. This is going to be a mixed number. A mixed number is going to be a whole number, and a proper fraction. Now, I say proper fraction, but again, please be careful. And just because it says proper fraction, you will sometimes see decimals here as well. Okay? Decimal here as well. A whole number and a proper fraction, a decimal combined. Okay? Now, let's continue, and we'll see what we're going to do with all of this information as I show you the process for this. Okay? Step 1. Sketch slide this up a little. I thought it was noisy at school, but I guess not. Sketch the rectangle. I'm not sure how much of that is coming through the microphone, but it's certainly entertaining on this end. Sketch the rectangle using the given dimensions. Now, they'll tell you, how long it is, how wide it is, or I'll tell you when we're talking about it during class time. Whatever the dimensions are, okay? Dimensions, make sure you're thinking length times width, right? Those are your dimensions. Sketch the rectangle using those dimensions. Now, I'm going to give you 3.5 centimeters by 6 centimeters. Okay. We're going to take this and we are going to turn it into a rectangle. We're going to sketch it out. This doesn't need to be perfect. I'm not asking you to measure anything. Please just make sure, though, that you are watching carefully for this mixed number. I'm going to show you how we can use the lines in the paper excuse me, to help us deal with that. But watch that mixed number. Sometimes it's first, sometimes it's second. Just be careful. Now, usually we've talked in class how the length is the longer and the width is shorter. Honestly, it doesn't really matter, but length, long, it just kind of makes sense. So that's what I usually do. So I am going to think about the length as my 6 centimeters. Okay. Now the width will go the other direction then. Like I said, it doesn't have to be perfect, and sometimes if the numbers are too big, this isn't going to work. But for 3.5, 1, 2, 3.5. Do you see how I went 1, 2, 3 lines and then about halfway into that one? Do the same thing here, and then connect them to make my rectangle. Now again, it doesn't have to be perfect, but I'm going to show you in a minute why, if you can use the lines to help you on your mixed number, I think it'll be a little bit easier for you. So again, here's our width on this side. We went with 3.5 centimeters. Is that actually 3.5 centimeters? No, but it's close enough. Length, 6 centimeters. That's not 6 centimeters at all, but should be fine. Now we have our sketch. So step 2. Step 2. Use tiling. Here we're talking about tiles again. Okay? Use tiling to visualize the area. To visualize the area. Now I know how much you all love it. I'm going to make you draw that rectangle again. Just like before, length, we'll just draw a long line. Ooh, let's get that focused, shall we? Come on, camera. There we are. Use tiling to visualize the area. There's my long line. For my width, I'm going to go down 1, 2, 3, and about half a line. 1, 2, 3, and half a line. Okay. There we go. Now the reason I did this, I'm going to start with the width. If I have 3.5 centimeters, that also means that I should be able to make 3.5 rows going across, going horizontally. I'm going to use the lines to help me. There's 2, 1, 2, 3, and if I split right here, hopefully you can see how that's 1, 2, 3, and then half of a row. Okay, that's why I kept trying to do that. Now again, if I had needed to do this, I don't know, let's say that this was turned that way, then maybe they'd be columns, but whatever. For right now, width was 3.5, width was 3.5, that means we're going to make 3.5 rows. So if the length is 6, okay, I'll go ahead and write width up here again. Width, 3.5 centimeters, so 3.5 rows. Length was 6 centimeters, and that means we're going to make 6 columns. Okay, 6 centimeters, 6 columns. 3.5 centimeters, 3.5 rows. Now with my columns, you could just go 2, 3, 4, 5, 6, but you know me, I usually like to start by getting my half, because it's easier for me to cut that into thirds, that into thirds, and that'll give me a total of 1, 2, 3, 4, 5, 6 columns. Okay. Now a lot of you probably know where we're going to go from here anyway, but let's wrap it up officially with step 3. For step 3, you're going to count the squares. Count the squares. Now be careful, because as you noticed, some of them are partial squares. We're going to count the squares, and this is where we get to use multiplication to check. Okay? Use multiplication to check. All right. Count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now that's 18 complete squares. So I'm going to start by writing that. I counted 18 full squares. And that's great, but we're not done. What about this stuff down here? This is only half a square, right? If I were to extend it down the rest of the way, that'd be the rest of my square. So 1/2 plus 1/2, that's 1 whole. Another half plus another half, there's a second whole. Another half and another half, there's a third whole, because half plus half is whole, right? I counted 18 full squares plus 6 half squares. I counted 18 full squares. Let's put a comma here. This is getting kind of long. Plus 6 half squares for another 3 full squares. Now, I didn't really do it on purpose. It's not usually going to line up that way, but it's pretty nice. That looks like an addition problem. That's what we're going to do. This gives me a total of 21 full square units. And they were centimeters in this case. I am going to include that because you know how important those units are to me. We'll include that. Here we go when we do our multiplication. Now, I didn't really leave a ton of space down here, but that's okay. Remember, it was 6 centimeters originally, 6 long, times 3 and 1/2 wide. The 6 is the same as 6 over 1. 2 times 3, remember 3 wholes made up of halves, okay? 2 times 3, that would be 6, plus 1 more is 7 halves. Okay. We multiply these together. Now I could, not here maybe, but I could do a little cross-canceling here. Divide by 2, and I would get my answer a lot faster. But we'll go ahead and I'll do the multiplication all the way across, just as review. 6 times 7 is 42. 1 times 2 is 2. And if I divide that, 42 divided by 2, 42 divided by 2 would be 21 centimeters squared. 21 centimeters squared. We will do some more like this together during our class time. In your Learn book, you have some space. We'll talk about that. You can do it on a piece of regular paper as well. We'll do more of these together. Hopefully, again, you're seeing it's just like the area we've been doing. The numbers are just a little more complex. All right, if you have any questions, make sure you note them down. Please have this written in your notes, and I will see you next time. All right. Thank you, ladies and gentlemen.